In this module, we'll be discussing of how to draw the ray diagram of a convex lens. So for drawing that, first you have to know the rules. The first rule states any ray that is parallel to the principal axis will pass through the focus. Rule number 2 says the ray that is passing through the focus will be parallel to the principal axis. And rule number 3, any ray that is passing through the optic center goes undeviated. Now next we have to know certain tips for drawing this ray diagram. So first draw a line and then mark 5 points at a distance of 2 cm each. Mark the points as 2F1, F1, O, F2 and 2F2. At the point O, draw a convex lens with a thin line in the center. Draw the object for a height of 1 or 1.5 cm above the principal axis. Please remember, the incident rays start from the head of the object and the point where the two refracted rays meet is the head of the image. Now, for drawing the ray diagrams, there needs to be two rays. Always, whatever might be the position of the object, we follow rule number 1 and rule number 3. Rule number 1 states the ray that is parallel passes through the focus. Rule number 3 says the ray that is passing through the optic center goes undeviated. So now we are going to see drawing of the ray diagrams for a convex lens. So while you are drawing the ray diagram for a convex lens, just the two rules. One rule is the ray that is parallel will pass through the focus. So please remember, in a case of the lens, it's getting refracted, so it goes to the other side. Now let us draw the rays. So your first ray is a ray that is parallel. So we are drawing a ray parallel and that ray will be passing through the focus. Please remember, you need to draw your arrow marks. That's very important. Now what is the next rule that you are going to follow? Always you follow the rule number 1 and rule number 3. The ray that is passing through the optic center just moves undeviated. So let us draw. So you can see it's just moving undeviated. So both the refracted rays are meeting at this point. Since it is meeting at that point, the image is formed at that position. So you get your image over here. So how is it? It is diminished. So it's real, inverted, diminished, and where it is being formed between F2 and 2F2. Here you have the object at 2F1. The same two rules. The first rule, third rule, ray parallel passing through the focus. The ray passing through the optic center goes undeviated. You can just see the image is formed at 2F2. It is real, inverted, same size. Now in this case, you have the object between F1 and 2F1. The same two rules. You can see the image to be formed beyond 2F1. Please don't memorize any of the positions. Just you have to draw the rays, you get it. So it is formed beyond 2F2, real, inverted, enlarged. In this case, the object is exactly at F1, the same two rules, but here you see the refracted rays to be parallel. So whenever you have the refracted rays to be parallel, it is at infinity, it's real, inverted, highly, and now here, look at this. So here you have the object between O and F1. So you are drawing the same two rays. It's moving through F2 and it is passing through O. But you can see they cannot meet anywhere this side. They are diverging. So it has to be somewhere on the same side. So you are just extending those two lines onto the same side. And you see that both the refracted rays are meeting somewhere this side. So since it is imaginary, you show it by dotted lines. And your image that is also formed is also imaginary. So you write it as virtual, erect. What is the size? Enlarged. Virtual, erect, enlarged. And where is it formed? It is formed on the same side. It can be formed anywhere on the same side, either at F1 or between F1 and 2F1 or beyond 2F1. It can be formed anywhere, but it is on the same side. So you write it on the same.